Now that you understand how these parametric trusses work, this is where things start to get really interesting. In this video, we're going to build a complete truss system for a simple sloped roof like this one. That includes truncated trusses, hip trusses, creeper trusses, and jack trusses. And here's the best part. All of these families are designed to work together automatically. Take a look at this. Everything lines up perfectly with almost no effort. All you really need to control is the distance from the truss to the wall, and the family takes care of the rest. So let's jump in and build the full system, shall we?
All right, let's continue now with the truncated and other trusses. If I take this truss and copy it 900 millimeters to the right, you'll notice it goes beyond the ridge. Actually, there are too many lines here, so I am going to hide the DWG file because we don't need it any longer. Yep, that's better. Now, if we jump into the 3D view, you can see the truss lifting above the roof. So clearly this one needs to be cut at the top, and that's what I call a truncated truss. I'll go back to the plan view and delete it. And instead of standard truss, I'll go to Project Browser and search for truncated truss. I'll drag it into the plan just like before and use the spacebar to rotate it until it's in the right position. Remember, the insertion point of these families is at the center, so I can place it anywhere along the ridge reference plane, or just place it roughly and then align it to the center. Now, since we need it 900 millimeters away from the previous truss, I'll select it, grab one of these points, snap it to the last truss, and then simply add 900 to the dimension. And there we go, it lands exactly where we need it. This is where global parameters really start to pay off. All we need to do now is go to Edit Type and assign the same parameters we used for the standard truss. So I'll rename this one TS1 for Truncated Standard. Since it's still part of the main roof, I'll keep using the main chord parameters. Now let's jump into the 3D view. You might see the truss looking a bit off, and that's because we haven't defined the truncated height yet. So I'll go back to the plan view and adjust the section so we can focus only on this truss. From here we can see that the height should be somewhere around here, roughly 1,800 millimeters. With a traditional truss, you'd have to calculate that value and input it manually. But not with this one. This parametric family works differently. Go back to the plan view and select the truss. You'll see this blue adjustment arrow. This arrow is linked to a parameter called distance to wall edge. It represents the distance from the truss to the outside face of the wall, perpendicular to the truss. Right now, it's not a clean value, so you have two options. You can read that value and type it in, or simply drag the arrow to the edge of the wall. I'll just drag it. And as you do this, you'll see the option to lock it. It's good practice to lock it. Now let's go back to the 3D view, and there you go. The truss height is automatically calculated based on the roof slope, and all the members are cut and positioned correctly. Take a look here. You can see there's a perfect gap at the hip, ready for the hip truss to fit in later. We'll get to that soon. Before that, let me show you why locking this distance is so important. If I select the truss, you can see the lock is active. That means if I move the truss, the distance updates automatically, and the entire geometry adapts to the new position. Let me rotate the view so you can see it better. Now I'll slowly move the truss. Notice how the diagonal members adjust as the truss moves up. And right around here, you'll see the internal configuration change from a W shape to an A shape, or even to a single diagonal depending on the spacing. If I keep moving it further, it starts creating more panels to match the span. Of course, there's a limit where the geometry stops making sense, but in real cases, you'll never push it that far. All right, I'll move it back to 900 millimeters from the previous truss and then copy it 2 more times. For each one, I just need to adjust the distance to the wall and lock it again. Now let's go back to the 3D view and have a look. You can see how nicely they line up, and they're already set up to receive hip trusses and jack trusses. Now I'll take the last one and duplicate it to create a girder truss. I'll rename it GT1. Since this is a new type, I need to assign the main parameters again. If you see this warning, it just means the distance to wall edge lost its constraint, so just lock it again. Let me check the distance though, because this looks too long for a girder truss. Yeah, that's too much. So I'll copy this girder truss another 900 millimeters to the right. And this one is no longer a girder, so I'll switch it back to ST1. Again, we lose the constraint, so I just move it into place and lock the distance to the wall again. Yeah, that looks a bit low, but that's fine, because this girder truss is going to be supported by this wall and the other wall, so it will work. All right, I'll save the file and continue with the hip truss. From the project browser, find the hip truss and drag it into the plan, just like before. Notice that this family is already rotated 45 degrees, so you can place it straight away. Also, the insertion point is now at the corner of the two walls where the hip should be. That means you can use the space bar to rotate it until it matches the corner you want. For example, here I press it a few times until it lines up correctly. The same applies to the other corners, just keep rotating until it points in the right direction. So I'll place the first hip right here, snapping exactly to the wall corner. To confirm the location, you can select the family and check the cross lines showing the insertion point. Now let's jump into the 3D view. Take a look at the shape of this truss. It should sit on top of the girder truss and align with the truncated trusses behind it. So, just like before, I'll assign the global parameters. If you've worked with trusses before, you probably know that hip trusses don't share the same slope as the main roof. This family calculates that automatically, so you don't need to worry. Just assign the same roof slope parameter. Now, once it's set up, you'll notice something is off. The bottom chord should align with the girder truss, but the orientation is wrong. So how do we know the correct orientation? If you go back to the plan view and select the truss, you'll see two indicators. One is the insertion point, and the other shows the direction of the ridge. Those lines represent the ridge, and the arrow shows the direction it should align with. In this case, the arrow is pointing toward the girder truss, but the actual ridge is in the opposite direction. So the truss needs to be flipped. There are two ways to fix it. The first one is simple. Place another hip truss on the opposite corner. Because of symmetry, that one will likely be correct. As you can see, this one points in the right direction, so I can delete the original and mirror this one using the ridge as the axis. So simply select the correct truss, go to Modify tab and select Mirror with Axis. And because you want to keep both trusses, make sure you get the copy box active right up here. Then select the reference plane aligned to the ridge, and that's it. The second method is to select the incorrect truss. Use Mirror, turn off Copy, and mirror it using itself as the axis. In this case, I'll use the first method. Now let's configure it properly. The top chord should intersect the truncated trusses, and the bottom chord should reach the girder truss. This family uses two distance parameters, very similar to truncated truss family. One controls the distance to the girder truss, or this distance shown here, and the other controls the distance to the ridge, which would be this one. You can adjust them using the arrows or by entering values manually. I'll drag this one to the ridge. For this family, locking is not necessary because the hip truss doesn't usually move. So, as always, you can move the arrows or you can measure the distance and input it manually in its respective parameter. Now I'll adjust the distance to the girder truss, measuring from the wall edge to the center of the truss. With this, the connection is guaranteed to match perfectly. Let me hide the roof slightly and isolate these trusses so you can see it clearly. Notice how the bottom chord aligns perfectly with the girder truss, and the truncated top aligns correctly as well. Another thing to show here is the top of the hip truss, to show that I'm going to stop hiding the roof and move to the top. Here you can see not only a 45-degree cut, but also the gap the hip truss leaves for the jack truss right in the middle. We'll see that later when modeling the jack truss. Now that the hip truss is ready, I'll go back to the plan view and mirror it to the other side, so I don't need to set up the opposite truss again. You can see how just by using the roof slope, everything stays consistent and realistic. I'll isolate them quickly so you can see how well they line up. Now let's move on to the jack truss. Find it in the project browser and place it in the plan. This one works very similar to the hip truss. It's not at 45 degrees, but the insertion point is still at the wall edge. Rotate it with the space bar until it matches the correct orientation, then place it. Use the align tool to move it and lock it to the center of the ridge. Now in 3D, you can see it behaves the same way. Back in plan view, select it and adjust the two distance parameters. One goes to the girder truss and the other goes to the intersection of the hips at the ridge. Let me quickly assign the global parameters here. Now the bottom chord aligns with the girder truss, and the top chord sits perfectly on the truncated chord. Once you get used to these families, the workflow becomes much faster. Now let's move to the creeper truss. These are usually located at the corners. Same process. Rotate it, place it at the wall edge, and make sure it's pointing in the right direction. If you don't see the eaves, just turn them on in the properties. Now in 3D, you can see it, but notice this one is flipped incorrectly. Luckily, this family's easier to fix. Just select it and use the flip control to mirror it. Now the orientation is correct, so the next step would be to assign the global parameters. However, I will cancel this process because for these creeper trusses in a corner, I will use a different family. Instead of placing each creeper truss one by one, I also created a family that includes up to 3 creeper trusses at once. This one is called Creeper Truss Corner Array. Place it in the corner, rotate it, and assign the same parameters. Back in 3D, you can see all the corner trusses are already in place. Now just mirror it to the opposite corner, making sure copy is active. At this point, half of the roof structure is basically done. Now we just need to fill this gap with jack trusses. I'll copy this one since it already has the distance to the girder set. Place it here and use the dimension to set it 900 millimeters from the last creeper truss. The distance to the girder is already correct, so I just need to adjust the length. Let me jump into 3D to show you this. Right now, the top chord doesn't match. That's because we need to adjust another parameter called central jack. When the truss is aligned with the ridge, the cut is 90 degrees. But this one is not centered, so I'll turn that parameter off. Now it switches to a 45-degree cut, matching the hip truss. Back in plan, I just drag this to align with the hip. Now in 3D, everything connects perfectly. From here, I just copy the remaining trusses and adjust their spacing. And that's it. Now I mirror everything, and this whole section is complete. Take a look in 3D. You now have a fully coordinated roof truss system that you simply can't achieve with standard families. This was the easy part. In real projects, things are usually more complex. So in the next video, we'll tackle a more challenging area where we'll use gable trusses, mono trusses, and valley trusses.